Math 1314, section IC1, spring 2022, Tyler Junior College. Homework 9.5 and 9.6, exponential and logarithmic equations. Video 7, solving logarithmic equations, part 3. Now, in parts, in the two previous videos, parts 1 and 2, we solved what I deemed type 1 logarithmic equations, in which some of the terms were logarithms and some were not. Without rewriting the entire how-to list, it basically went this way. Get it to where it says a log equals a number, rewrite in exponential form, solve, check for extraneous solutions. Well, now we're going to move to type 2 log equations. And again, this is my own personal notation. It's not official notation. A type 2 logarithmic equations. Type 2 logarithmic equations are equations in which all terms are logarithms, such as this one. Log base 5 of 4x minus 4 equals log base 5 of 3x, or this one. Natural log of x plus natural log of x minus 10 is equal to the natural log of 9x minus 8. Notice that all three terms are separated by addition and subtractions. All three terms in this equation are logs, and all two terms in this equation are logs. There is no term that doesn't have a log parked in front of it. Now, how does this differ from solving a type 1 equation? Well, let's talk about the main idea, and then it's going to turn into a list by the end of this video. Remember that the whole genesis of logarithms was an effort to find the inverse function of an exponential function. And so log is the inverse of exponential functions. But if one thing's the inverse of something, then it goes both ways around, which means exponential functions are the inverse of logarithms. Well, since logarithms are invertible, that means that they're 1-to-1, which means the only way they can be equal is if their insides are equal. In other words, the only way things can come out of a logarithm and be equal with the same base is if they went in equal. Now, what does that mean here? Well, it's real simple. If you have, let me fix this, it's the wrong color and it is the wrong font size. If you have log equals log, and what I specifically mean is one log on the left and one log on the right, and it should be said with the same bases, then you can just cancel the logs and equate the arguments. In other words, set the arguments equal to each other. Now, it's important to point out that this only works when there's exactly one log on both sides, which is what we have here. So in this problem, what we can basically do is take our equation, log base 5 of 4x minus 4 equals log base 5 of 3x. And because I have one log equal to one log and the bases are the same, we can basically cancel the logs and continue solving. 4x minus 4 is equal to 3x. And again, I want to stress that this only works when you have exactly one log on the left and exactly one log on the right. Any deviation from that, and you cannot cancel the logs. Now, this equation is pretty easy to solve. Yes, it has x's on both sides, but that's not a problem. All we have to do is fix the fact that there are x's on both sides by getting rid of one of them. My personal preference is to get rid of the smaller of the two. And I can do that by subtracting 3x from both sides. I know my long-term goal is to get the x by itself. And honestly, subtracting 4x from both sides would be a little bit more towards that goal. But I like keeping my x's positive when I can. 4x minus 3x is 1x, or just x. Minus 4, and on the right side, everything canceled. Now it just says x minus 4 is equal to 0. This means x is equal to 4. So pretty easy move. We just cancel the logs. But a couple of things. Number one, that won't work here. That only works when you have one log equal to one log, which we do not have here. We have two logs equal to one log, or rather the sum of two logs equals one log. And number two, extraneous solutions can sneak in. Now, I didn't mention it here, but we can check it real quick. If I take that 4 that I claim as the solution, well, it is the solution, and I substitute that 4 back here, I get 3 times 2 is 12. That's not negative. We're okay. And if I put the 4 here, I get 4 times 4 minus 4. 4 times 4 is 16, minus 4 is 12. But the important thing is our solution does not make any negative arguments in the original logarithm, so it's keeper. Excuse me, you didn't need to see that. Now, how are we going to do this one? Well, this is a situation that we encountered in the end of the previous video, or in the previous video. We have two logs where we want one, and that is a dead giveaway that we should condense. So first thing we're going to do is condense the left side into one log. We can do that using the product rule because of the plus in between the two logs. I know there's at least one homework problem where you have to use the quotient rule. Keep an eye out for it. If we condense the two logs that are in the red box, we can write one logarithm and multiply the two logarithms' arguments. The first argument is x, the second argument is x minus 10. And so there's the left side condensed into one log, and that's still equal to the right side. And once we've condensed them, then we can cancel the logs. And again, this cancel the logs move only works when you have one log equal to one log, which is what we have now. If we cancel the logs and equate the arguments, we get x times x minus 10 is equal to 9x minus 88. Now, if this said x equals, it would be done, but guess what? It doesn't. So now we have to finish solving this equation. Well, if we're going to solve this, the first thing we need to do is get rid of the parentheses because there's an x trapped inside of them. But upon distributing, to get rid of the parentheses, you'll probably immediately rue the fact that we're about to get a quadratic. X times x is x squared. X times negative 10 is negative 10x. And on the right side, we just have 9x minus 88. Now, time to shift gears. We got rid of the log because that freed up the x's. But now we created an x squared. This is a quadratic equation. And just like in the previous example in the last video, or the final example in the last video, when you're solving a quadratic equation, you really want to get it equal to 0, and it would be preferable if you could keep the squared term positive. Because the x squared is already positive, I do not want to move it to the right side. I'm going to keep it on the left side, so everything is going to go on the left side, which means we're going to empty out the right side. We can get rid of the 9x on the right by subtracting 9x. If you were thinking divide by 9, you were talking about getting rid of just the 9. I need to get rid of the 9x as a term. And to get rid of the minus 88, we can do plus 88 on both sides. Getting a little crowded here, but that's okay. The right side of the equation completely cancels. That was the whole reason we did those moves, and that leaves a 0. On the left side, we have just an x squared. But we have a negative 10x and a negative 9x, which is negative 18x, and then the plus 88. Now, quadratic equation equal to 0. Feel free to get out the quadratic formula, but I told you in the last video, if you run across a quadratic equation in any of these particular problems, it will factor. So if your factoring skills are decent, I would consider it. This one might look tough because I need two numbers that add to give negative 19. But multiply to give positive 88. Well, I know it would have to be two negative numbers. They have to be the same sign to multiply to give a positive 88, but they have to combine to make a negative 19. So it has to be two negatives. And then I would focus on how you can multiply and give 88. And the one way that jumps out at me right away is 8 times 11, which happens to be the right pair because negative 8 times negative 11 is positive 88, but negative 8 plus negative 11 is negative 19. And now that it's factored and equal to 0, we can set each factor equal to 0. X minus 8 is equal to 0. X minus 11 is equal to 0. And then when we solve, we get x equals 8. And we get x equals 11. Or do we? Remember, part of solving logarithmic equations is to check for extraneous solutions. So we have to do that. Check for extraneous solutions. Meaning, do any of the solutions that we came up with, which were 8 and 11, do any of those make any original argument negative? Well, the original equation is right there. Natural log of x plus natural log of x minus 10 equals a natural log of 9x minus 88. Let's focus on the 8, which by itself is nice and positive. But what happens when I put that 8 here? Well, nothing. It stays an 8 and it stays positive, so it's okay there. But what happens when I put the 8 there? I get the natural log of 8 minus 10, which is the natural log of negative 2. That 8 is not negative, but it makes one of the original log's arguments negative, and that's enough to throw it away. It just so happens that the 8 would cause the same problem over here, because we would get 9 times 8 is 72. 72 minus 88 is negative because 88 is bigger than 72. So because of what the 8 does in 2 out of the 3 arguments, the 8 is not good. Let's type that down here. X equals 8 is extraneous. It makes, that's supposed to be a colon. It makes 2 original arguments negative. So we have to throw it out. However, as far as x equals 11, we could just spot check that real quick. Putting the 11 here is not a problem because it just says x, so we're okay there. Putting the 11 there gives us 11 minus 10, which is positive. And putting 11 here gives us 99 minus 88, which is positive. So the 11 is not causing problems, which means that we can just follow that up and say that x equals 11 is good. It makes no original argument negative. So the only solution is x equals 11. I want to wrap up this video with the how-to list. How to solve type 2 logarithmic equations. Number 1, if necessary, manipulate the equation until it reads log equals log. This usually involves condensing one side or both sides into one log. Number 2, cancel the logs. Number 3, solve. Number 4, check for extraneous solutions. This is the last video I'm making. There are a couple of word problems at the end of this homework assignment that involve logarithms, but it's basically just setting up an equation they give you and then solving it, checking for extraneous solutions. And as a bonus for those of you who watch these videos and have watched this video all the way until the end, there is going to be a short test over the last 3 homework assignments, all from chapter 9. If you are bothering to watch this video, because my YouTube count says that not many of you do, but if you are watching this video, then I want you to either text me or message me the following word. What word shall it be? Let's just say Star Wars. That's 2 words. That's okay. I want you to text me at 903-445-6510 or send me a message through Canvas that simply says Star Wars, so that I know that you not only watch this video to the end, but you saw this word and are doing this. And as a reward for doing that, as a reward for watching this video, I will give you a 90 on the last test without having to take it.